Now the next important study is the segment of a circle. Now what is this segment? Again, it is the region of a circle enclosed by a chord and its corresponding arc. If I take the chord AB here, then there is arc AB and a chord AB. AB is the chord, arc AB, they enclose a certain portion of the circle, that is the region of circle known as the segment of a circle. So the region of a circle enclosed by a chord and its corresponding arc is called as the segment of the circle. Now if the arc is a minor arc, then this region is called as the minor segment, and if the arc is a major arc, that is BA, then it is a major segment. Therefore we define the minor segment as the region of a circle bounded by a chord and the corresponding minor arc, and in the figure ABA is minor segment. Now the major segment is the region of a circle bounded by a chord and its corresponding major arc. AB here is the major arc, and that region, that is BAB, is the major segment. Remember that. Now we have to learn how to find out the area of minor segment. The area of minor segment, if you want to find out, then the procedure is slightly different. We have to first join OA and OB and get the minor sector. The minor sector is ABOA, and we also get a triangle AOB. So from the area of the minor sector ABOA, if I subtract the area of the triangle AOB, I get the area of the minor segment. Again I'll repeat, the area of minor segment is equal to the area of the minor sector, that is ABOA, subtracting the area of triangle AOB from it, we get the area of the minor segment. So that is exactly I have written here. Area of minor segment ABA is equal to area of minor sector AOBA minus area of triangle AOB. Area of minor sector, already we know the formula is theta by 360 into pi r square minus area of triangle AOB. Now the question is how to find the area of triangle AOB. The area of triangle AOB, if it is a equilateral triangle, the formula is root 3a square by 4. And if it is any triangle, we can use the formula half r square sine theta. Therefore area of triangle is half r square sine theta. Therefore generally we use half r square sine theta. Therefore area of minor segment is theta by 360 into pi r square minus half r square sine theta. Now let us understand how we got this half r square sine theta for area of a triangle. Now if you take the triangle AOB, then OA and OB are radii, then drawing a perpendicular BQ to OA. Now let us understand the area of this triangle AOB is equal to half into base into height, that is half into OA is the base into height is BQ. Now we can find out BQ using the trigonometric ratio sine. Therefore this is the central angle for the arc. Therefore if I take this theta as the central angle, then sine theta is equal to BQ upon OB, and therefore that is equal to BQ upon R, because OB is R, and therefore BQ is equal to R sine theta. Substituting the value of BQ here, we get half R into R sine theta, or half R square sine theta. Therefore area of triangle AOB is half R square sine theta, that is I have substituted here. Therefore remember, to find out the area of a minor segment, then find out the area of the minor sector, subtract the area of the triangle. Using the relation half r square sine theta, we can find out the area of triangle. Subtract from the area of minor sector the area of the triangle, will get the area of the minor segment ABA. Now to find out the area of major segment is very easy again. Find the area of the circle first. Find the area of the area of the circle. Find the area of the minor segment. Subtract the area of the minor segment from the area of the circle. We will get the area of the major segment. Therefore, area of major segment is equal to area of circle minus area of minor segment. Therefore, pi r square minus then theta by 360 into pi r square minus half r square sine theta. This is the area of the minor segment. We will get the area of the major segment. So remember that. Now the procedure is simple. Find the area of the circle first, find the area of the minor sector, find the area of the triangle, subtract the area of triangle from minor sector, we will get the area of minor segment, and then go for finding out the area of major segment by subtracting the area of minor segment from the area of circle. A very simple procedure. Of course it is slightly lengthy procedure, but in 5 steps you will be solving it and you will get the answer correctly. It is almost 4 to 5 marks question generally asked. Now length of an arc of a sector of angle theta. Now how do we find the length of an arc? See, in this circle with center O, we have an arc AB, its length is L. We want to find out the length of this arc. Now to find the length of the arc, let us understand this. The arc AB subtends an angle theta at the center. As you know that if theta increases, the length of the arc also increases. Therefore, the length is proportional to theta. So I can take a ratio of length of arc divided by circumference of circle, that is equal to theta upon 360, because the L is proportional to theta and the circumference of circle, when we take the full circle, then the angle at the center is 360 degrees. Using this relation, we can go for finding out the length of the arc, that is theta by 360 into circumference of circle, that is theta by 360 into c. L is equal to theta by 360 into 2 pi r. So remember this relation for finding out the length of an arc. Now the next important discussion is how to find the area of minor sector given length of the arc and the radius of the circle. Here please understand, here the central angle of the arc is not given to you. Therefore let us see how to find the area of minor sector. Theta of the sector is not given. We are given the length of the arc and the radius of the circle. Now we know that area of minor sector formula is theta by 360 into pi r square, and also we know the length of the arc here, L is equal to theta by 360 into pi r. So let us manipulate this formula. Area of minor sector is equal to theta by 360 into 2 by 2 into pi r into r. I have just taken 2 by 2 here. 2 by 2 is 1. There won't be any change in the equation. So theta by 360 2 pi r into half r, and you know that this formula theta by 360 into 2 pi r is nothing but L, and that is equal to L into half r or half LR. That means the formula to find out the area of minor sector, we have two formulas. One is theta by 360 into pi r square when theta is given to us, but here the formula used is half LR when the length of the arc is given and the radius of the circle is given. So please remember, this is a very important formula to find out the area of minor sector when the length of the arc and the radius of the circle is given. So these are two very important formulas to find the area of minor sector. So until now we have discussed the different formulas to find out the areas of circles, that is area of minor sector, major sector, minor segment, major segment, area of circle. So these are very important formulas which you have to remember and use them to find out the areas asked. Okay, note down and keep it as a reference for you. Thank you.